question 6, you really need to know your qualitative analysis tests and have learned them well and be able to apply them to some slightly unfamiliar scenarios. So the first one, think about the fact that it contains potassium ions, aluminium ions and sulfate ions. If you know your flame tests, you only need to know a limited number of flame tests. Aluminium we never do in a flame test, sulfate we never do in a flame test. You just have to remember that potassium gives you a lilac flame every time. Then, understanding how the precipitation reactions work with ionic equations was necessary for part B. In order to form aluminium hydroxide, as a product, every time you've got a precipitation reaction, the point is the precipitate formed is a solid, and it's always just formed from the ions that make up that solid. So in this case, the ions are an aluminium ion and 3 hydroxide ions. They start out life aqueous, which is how you end up with the precipitate to begin with. So you've got to mix together 2 solutions when you form the solid aluminium hydroxide. And that would be the same if you were forming silver chloride or barium sulfate or any of the other precipitates that form in the qualitative analysis section. Learning the test of sulfate ion just meant that you needed to know that you add barium chloride solution, hydrochloric acid, which removes any carbonate present that might give you a false positive test. You could have used barium nitrate and nitric acid would have been fine as well, and the result is a white precipitate of, in this case, you can have barium sulfate, which is insoluble as that precipitate. Tricky question here, and there's lots of different ways of answering it. Only one is going to help you with the second part of question D. You've got to sort of figure out how you can combine potassium ions, aluminium ions and sulfate ions so that there's no overall charge in this compound. So the K's are +1, the aluminiums are +3 and the sulfates are -2. The easiest thing to do is just to have 2 sulfate ions, which gives you a total negative charge of 4, and then 1 potassium ion and 1 aluminium ion, which gives you a total positive charge of +4, and therefore overall that gets you X, i.e. the number of potassiums as being 1, Y, the number of aluminiums as being 1, and Z, the number of sulfates as being 2. Using this information, we can do the next question, which is to put those numbers back into this formula. So if it's KAlSO4 twice dot NH2O, you're told effectively this whole thing has got a formula mass of 474. And I'm just going to move that down. This part you can calculate the formula mass of. This part is water, which you can also calculate the formula mass of. And then you just have to add it together to work out what N must be. So the KAlSO4 twice bit has a formula mass of 258. Water's got a mass of 18. So effectively the multiplication sum you're working out, if you like. So effectively what you're working out is all of that we can say that 474 is equal to 258 plus n lots of 18. And if you solve that for n, you end up with n lots of 18 equals 474 minus 258, which is 216. and then n becomes 216 over 18, which is 12.